All right, well, let's get started. First of all, thanks very much, Sam, for coming by. And it's a topic that's dear to my heart about recruiting undergraduates and looking at trainee teachers. Sam will be talking about some of his most recent research in this topic. So thank you very much. And we look forward, usually we talk for about 30 to 45 minutes, somewhere in there, and then we have questions after.
Great, lovely.
And people online, please feel free to pose questions, and I'll be monitoring the chat function so we can pose those questions at the end. Thank you very much.
Thanks. Is there anywhere I should stand such that people online can see me, or shall I just?
I think
face towards you guys. Okay. Yes. Thanks very much for having me. So I'll be talking about this project, understanding the decision to not become a teacher. Hi there. Survey experiments with undergraduates and trainee teachers. And just a bit of prior warning: we've done the undergraduate stage of the research, and I'll be presenting that. The trainee teacher stage is sort of happening during 2025, so there's not going to be any data on that yet. This is work in progress, and this has been done by a colleague, Claire Routledge, who's a former teacher and works at the CPO with us. Right, so the motivation for this work, just two simple graphs taken from the NFER's annual report, which very helpfully summarizes the kind of DfE administrative data on teacher numbers. So on the left-hand side, you can see postgraduate ITT recruitment versus the target. And the target is set in a complicated but rational way, which such that if you reach 100% of it, then you're supposed to have roughly enough teachers in the system. So there's many assumptions built into that. And you can see that for secondary, we haven't really been recruiting enough teachers, well, for the duration of the graph, apart from COVID. For primary, the situation's a bit different, but we're now not quite recruiting enough teachers just in the most recent year in the data 23-24. And then you look at the breakdown by subject. This is a well-known finding, which is held for a long time, that almost all of the secondary subjects are not recruiting 100% of targets. And some of these is now very severe. For example, physics, in the most recent year, we recruited 17% of our targets. And that reflects, poor numbers coming in this year, and also a sort of cumulative deficits of recruitment in previous years, such that the targets are getting more ambitious. Okay, so that's the situation in England. This is a very common pattern. You can see similar patterns to this in the US and other kind of high-wage countries. Another way of looking at a way of thinking about the sort of solution to this is that there is, in some sense, a sort of pipeline of recruitment into teaching. And so this graph shows that pipeline just for maths. And so on the left, you can see in this sort of first column, by math grads, I mean those leaving an undergraduate maths degree in England each year. There's about 10,000 of them. The government is looking to recruit those into initial teacher education, ITE, on this graph, which in a traditional sort of pipeline, this is a bit stylized, would happen the year after they finish their undergrad. They'd be qualified and eligible to enter a maths ITE program at that point. We managed to get about 2,000 of those, in 2014-15. And then after that, we watch people choose to enter the profession or not. Many people choose not to enter the profession having done their initial teacher education, despite having a qualification and being legally, allowed to do so. And then we see people sort of slowly leaving the profession in subsequent years. The point I'm trying to make with this graph, which is a bit rhetorical, is that, clearly we're losing a lot of people here. So even a small percentage change in our ability to get people from this stage to this stage would bring in a large absolute number of teachers to the next stage of the pipeline. There is a pretty large evidence base on this subject. People have used interviews with teachers. There's a large amount of traditional survey research, including recent work by Stephen Gorard and others, and many papers by Richardson and Watt, which have largely surveyed existing teachers to understand their motivation for coming into teaching in the first place. And a few papers using cohort studies where retrospectively you're able to watch people coming from education into the labour market and a subset of those people into teaching. So a data set that looks much more like this kind of stylized representation of the pipeline. It's kind of hard to summarize all of this stuff because many variables have been implicated in this. So I've just got these quotes from two recent reviews, one by Frey and Gore from Australia. Collectively, the 70 articles in this topic highlight that interest in teaching is affected by a range of individual and societal factors, especially intrinsic and altruistic motivations. So these are kind of other regarding reasons. I wanted to enter teaching to have a social impact, for the benefit of children, etc. Increasing opportunity for kids, that kind of thing. And then slightly more recently, again from the Durham team, in summary, across countries in Europe, USA, Australia, and New Zealand, i.e. high wage kind of English speaking countries, highest rate of motivations for choosing teaching among pre-service teachers were the intrinsic reasons and the altruistic value of teaching. So reaching roughly the same conclusion. There is more nuance in that paper, but that seems to be the representative quote about kind of high wage countries. So, as with any evidence-based, there's a number of limitations. I think a particularly important one is this idea of social desirability bias, such that if you just ask somebody why they do something and let them speak freely or allow them to choose from a list of options in more of a survey type way, one concern of unknown sort of size, unknown significance, is that respondents are likely to sort of downplay the importance of extrinsic rewards. Not many people say I'm here for the money, and perhaps in line with that kind of amplify the intrinsic rewards as their reason for doing something. It's easier to say I'm in teaching for the kids than it is to say I'm in it for the money. It's more socially normative to say the former. We don't know how large this issue is. It could be small, could be non-existent. There's some evidence that only certain types of people do that. Some people seem to be immune to it and just a bit more honest, I suppose. But this is interesting and important to look at. Respondents who are not planning to enter teaching may not even have considered it. And it's kind of, if you ask somebody who hasn't put a lot of thought into why they want to do any job, I didn't know which job I wanted to do when I left my final year of my undergraduate, and you ask them, would you like to be a teacher? If yes, why? If no, why not? It's kind of hard to elicit meaningful, kind of reflective responses from them. They may just not have considered it. They may start just sort of talking to fill the gap. Again, don't know how important this is, but it's a concern. Of the studies that look at existing teachers, I think this is a very useful exercise to do, but this is a very particular group, right? It's those that have already chosen to go into teaching. And from a policy point of view, you're more interested in what are the motivations of the marginal person who just doesn't go into teaching, right? The person who was closest to going into it, but actually for whatever reason didn't. And that person may have very different preferences and reasoning to the average of all the people who decided to go in. I think that's an interesting thing to explore. And then for me, this is one of the most important limitations, is that there's a danger that this kind of large literature ends up just generating a longer and longer list of variables. Sorry, yes, I meant to go back. Sorry, yeah. Okay. Sorry, this literature here, there's a risk of it sort of just generating a longer and longer list of correlates, which from a policy point of view is arguably not that helpful if we don't know kind of which of them are most important or what are the policy trade-offs and so on. And I'll talk more about that as I go along. Okay. Don't think there are any questions yet. All right, so what do we do in this project? In the data I'm going to present today, we survey almost 900 undergraduate students in England. We did do this via an online survey platform, which I'll talk about. And we use this as an opportunity to implement a full factorial job choice survey experiment, which I'll talk about in some detail. This is pre-registered. And essentially what we do is experimentally vary the values of 10 job attributes. I'll talk a lot more about what that means, and get our respondents to make hypothetical job choices. Ask them essentially, do you prefer this job on the left or the job on the right? And this allows us to look at allows us to measure people's preferences for different job attributes. It allows us to measure people's response to varying the values of those job attributes. If you increase salary by 10%, what does this do to people's choices? Those are two separate things. And it allows us to look at heterogeneity by subgroups. So we look at it based on degree subject. Are the STEM subjects where the shortages are worse? Is that because they want something different from jobs? Personality type, and also this idea of public service motivation, which I'll go on to talk about. And this addresses my my last limitation here. This method allows us to quantify the salary equivalent value of different job attributes. So you can put everything on a common monetary metric, which is helpful from a policy point of view in terms of thinking through, are some of these ways of making teaching more attractive? Can they be implemented at like a lower cash cost than others? Yeah, I'll show some results on that. Okay, so this idea of a factorial survey experiment. So it is a survey, funnily enough. So we're just asking people to respond remotely to some sort of stimuli. You can think of it as like a paper and pencil based exercise, but it's online. It's factorial in that we experimentally vary many attributes all at once. And again, I'll show examples of this in a minute. And it's an experiment. So the jobs that we're asking people to judge are composed on a bunch of randomly chosen job attributes. And again, I'll show some examples of that. These are also sometimes called conjoint experiments or discrete choice experiments. And they usually use incentivized responses. So for example, in our paper, we paid people about £3 to respond to this survey. Okay, so here is an example of one of these job choice survey experiments. This is the stimulus that the respondent to the survey would actually look at. And you can see that each column in this table is a different job. There's always two. So people are just comparing left and right, which psychology suggests people are very good at doing. Each row is a different attribute. So for example, this row is flexibility over working hours. And then each cell is a randomly assigned value of that attribute. So for example, frequency of working with young people. You can see that on the left, it takes the value daily, on the right, it takes the value weekly. There's a finite list of values that can come up in those cells, and we just randomly assign it for both jobs in the table. And so you can see how the jobs end up being a collection of randomly assigned attribute values. There's 10 of them here. And we just ask participants to select, would you prefer to do the left job or do the right job? It's a hypothetical exercise. We ask them to assume that everything else about these jobs is equivalent, but of course we can't guarantee that that's what's happening in their heads. And each individual that responds to our survey does 10 of these choice tasks, where each choice task will have a different job bundle of attribute values on the left and a different job bundle of attribute values on the right. And this is our job choice survey experiment. So,
can you just go back for a second? Yeah. Like, so does each of the rows have, like, how many choices are you manipulating? Like daily, yeah, weekly? Is that just daily or weekly, or are there other options?
So there's about 4 for each attribute, and I will show you what the full set of possibilities is.
So the respondent always should select one of two options?
Yeah, they have to select one or the other. Yeah, they can't select both, or they can't select none. Yeah. Okay, so what is the sort of strengths and limitations of this method? Usually people save this for the end. I think get straight to it. It's efficient, so we can study 10 different treatments at once. We can, randomize 10 different things about these jobs. And also, because each respondent does 10 choice tasks, which involves evaluating a total of 20 jobs, we end up with many, many jobs being evaluated in our sample. this isn't definitive research, but some very nice research suggests that this reduces social desirability bias by about 2/3. Briefly, the way they do this is by running a full factorial version of one of these experiments. And then, so participants are either assigned to that, or they're assigned to a sort of manipulated job choice survey experiment that looks the same, except for only one of the characteristics varies between left and right. And that characteristic is one that we might expect people to have a social desirability bias type response to it. And by comparing the results between those two with another experiment, the machinery is quite complicated, but they're able to get an estimate of the reduction in social desirability bias. This paper by Horiuchi is very interesting. It's in political analysis. The intuition for this is just that, you know, a certain number of these attributes are likely to have some sort of social desirability bias. Not all of them, or it's unlikely that all of them would. And because you're always getting people to compare between two options where the socially desirable attributes, you know, are just a subset of the attributes, it sort of nets it out in some sense. This is the informal intuition. There's socially desirable things on the left, there's socially desirable things on the right, which is unlike saying, from this list of 8 things, you know, helping children, money, etc., which ones are important to you, right? There's no netting out of any of the social desirability of those things. And we can estimate these cash equivalent values of the different attributes that I said before. But there are many weaknesses or limitations. You know, what if people assume that this attribute sort of, maybe they have had a job that looked a bit like that before, and so mentally they're sort of like bundling into that job some stuff they associated with the job they had that looked like that before. This is called a uncontrolled variable or uncontrolled attribute. You can try to deal with it by having more attributes here, such that just more of them are controlled. But people's cognitive ability to, you know, if you had 100 attributes for each job, people just wouldn't be able to compare it. So it's a sort of, it's a trade-off. Construct validity. So it has high internal validity because you're randomizing the attribute values. It has reasonably good external validity. You can get big samples. You can do, you know, heterogeneity analysis. But the construct validity, frankly, is not great, right? So some of these things are quite simplistically expressed. For example, frequency of working with young people daily, weekly. It's kind of a crude way of getting at the idea of, you know, what do people care about in terms of working with young people. Obviously, we try to write the attributes and the values as well as we can to try and mitigate this.
Did you choose young people versus children and young people quite deliberately?
Yeah, we chose young people, yes, deliberately. We're trying to get a primary and secondary, and yeah. Yeah, and also, you know, as with any online survey, there's always concerns about how attentive are the people taking part. You know, they may just be bashing through it to get their £3.50 at the end and not being that thoughtful, but we've got various ways to try and mitigate this, which I'll talk through. In mitigation, there are various papers showing that job choice survey experiments, the preference measurements you get are predictive of the jobs that people subsequently go on to do in their next job. So the stuff that we measure hypothetically online is aligned with subsequent behavior in the real world, which is reassuring. Like, if that wasn't the case, I think there'd be good reason for skepticism about what we're really learning from these studies. Okay, so these are the attributes and values that we put into our survey. The first bunch are around working patterns that you can see on this slide. The first attribute is typical working hours per week, and we've got 4 values of this. In each case, we try to pick one which looks like the situation in teaching in England, and then some other interesting kind of benchmark comparators. So, for example, survey data shows that non-leader teachers in England work a 52-hour term time week, so that's one of our attribute values. And, you know, theoretically, we're all working sort of 5 8-hour days on full-time contracts, so that's one of our other values. And then we put some others, you know, to get a sense of how people respond to wider variation. Paid leave per year. So 6 weeks per year is the legal minimum statutory allowance in England. Teachers get 13 weeks per year paid leave, which is quite a lot more than that. Obviously, it's all outside of term time. And then some academy trusts are now experimenting with giving all their teachers 1 day off per fortnight paid leave. So it's called the 9-day working fortnight. And if you equate this to the number of weeks per year, that amounts to having about 17 weeks per year off, but you don't choose when it is. Days worked from home. Since the pandemic, many graduates are working 2 to 4 days a week from home. Some academics work more than that from home. With teachers, the equivalent figure is 0. This is now a big difference between teaching and non-teaching professions. And then we've got one about flexibility over working hours. Are you able to shift the hours by in which you do your work? So I have quite a lot of flexibility over that. Teachers, you just have to be on site during the school day for all the hours in the school day. Simple as that. Second bunch of attributes we put in there is job characteristics. So this is more like task characteristics, maybe a better word than that. Does it use knowledge from your undergraduate degree? Never weekly, daily. Some people have argued that those with STEM undergraduate degrees place a greater emphasis on going into teaching because they love their subject as opposed to other reasons, and we wanted to test this explanation. Frequency of working with young people. Clearly, teachers do it all the time, but many graduates never do. And level of social or community impact you can make. This is this is quite vague. There's what exactly do we mean by social or community impact? And really, it's just whatever people have in their head when they're reading our survey. Also, what do we really mean by moderate, significant, etc.? Again, it's just whatever's in the head of the survey respondent. This was the best version of the wording we could come up with, and we think it's a super important attribute to have in there, given our research question. But yeah, I acknowledge the limitations of it. Then lastly, we've got a bunch of stuff around pay. Starting salary per year before tax. So recent data suggests that graduate starting salaries in England are about 28,500. This year, the situation outside of London for a beginning teacher is 31,500. And then for our kind of stretch, very ambitious reform value in Boston, teachers get paid, if you just, convert it using current exchange rates, about £49,000 a year. We've also got employer payments to pension pots. So the idea is that and we piloted this extensively to make sure that respondents were understanding it in the way we wanted them to. What percent of your salary does your employer pay into your pension pot over and above your salary each year? The real figure in England for teachers on defined benefit pensions from a school's point of view is actually about 28%, very, very high. But that doesn't necessarily mean that the teacher gets it because it's a defined benefit scheme, not a defined contribution scheme. Salaries, pensions are very technical, but this is the least bad way we could think of operationalizing this. And also because the government's been experimenting with one-off cash retention payments for early career teachers, we thought it'd be interesting to put this into the mix and see whether that has any effect on, how desirable people perceive going into the occupation in the first place would be. These are all values of real policies that have been used recently. Okay, so as a reminder, our job choice survey experiment, our choice tasks, are going to present repeated pairs of jobs comprised of these attributes, where each attribute randomly takes on one of these possible values. So it's going to look something like this, and we just aggregate the data online. We look at some different moderators. So we have a sort of binary comparison of those who did maths, physics, or engineering undergrad degrees versus people who did any other type of undergrad degree. We measure people's public service motivation, this idea of like compassion and civic duty. And we just use a median split in this analysis, people above the average on that versus below the average.
It's in kind of combined.
Yeah, so this is actually has 3 subscales in the short version of this instrument.
One thing I wasn't sure whether there were like 2 subscales, and you were
Yeah.
Because do you need them to be both of these things, right? Is it interactive?
Yeah. So the full version of the short scale has 3 subscales. One of them is how attracted you are to policy making, which we thought was not really relevant. So we just have these 2, and the current version of the analysis just smushes these into one factor. So we just haven't got around to doing a more sophisticated version of the analysis yet, but we will report it separately. And we just report it based on a median split at the moment. And then we also look at one aspect of Big 5 personality, openness to new experience. So these are, if you score highly on this, you're highly receptive to like new ideas, experiences, meeting people. One of the subscales is curiosity, that kind of thing. This is the characteristics of our sample. So the median respondent is 23, which is a little bit older than I thought it would be. Anybody who's an undergraduate student declares themselves an undergraduate student on prolific is potentially eligible for the survey. It suggests to me that maybe we've got some people who have recently finished their undergraduate degree, or many mature students perhaps.
Yeah, I should say our prolific sample of about 1,000 undergraduates. Mean age was 25.
Okay.
26. Yeah, it was like something's going on there, but yeah, that's all right.
Yeah.
You could see like the actual distribution.
Okay. Yes.
The tail thing, or what's going on.
Yeah. I'll add that to the slides.
I look forward to seeing on Thursday.
Yeah. Fast iteration.
Can I just ask why you picked the personality openness to experience rather than say extroversion? Because I think that's often been correlated with teaching interest.
Right. So I have a paper from my PhD 14 years ago where I showed them the understanding society data that tracking people into the workforce, the only aspect of the Big 5 that was correlated with entry to teaching was openness. And so, yes, I've always been looking out for other ways of kind of testing that. And so that's why we adopted it here. I mean, theoretically, you can also think that like curiosity about ideas and interest in meeting new people might orientate you towards a career in teaching, because, you're teaching ideas to people that you haven't met before. And so,
but okay, no,
yeah.
That's fine. I'm just curious.
Yep. Mostly from the UK, but some larger minority groups like Nigerians, which I think aligns with, the breakdown of the undergraduate population in England. We want to get a third column on here, which is, what you'd expect based on data about the undergraduate population, but we haven't got there. More females than males. A high proportion of our respondents report having some type of employment while doing their undergraduate degree. So this could be sort of holiday employment, or it could be part-time employment while at university. This is now very common in England for undergraduates to do this. Again, I'd be interested in seeing what the number is in the population. And we end up with 900 respondents, 9,000 choice tasks, and 18,000 evaluated profiles. Okay, last thing before results is some quality control checks. We try to do as much as we can here to ensure the quality of our sample. So Prolific has some built-in tools for doing this, like a recapture to keep bots out. And we filter, you won't see any results from somebody who got a poor recapture score. We have these attention check things where we just ask people, please choose option C, and that's all the question is. And if people choose the wrong option on that, we just take them out of the sample and don't include them. There's also
need conjoint experiments that you imagine, as it were, that nothing can be done about it now anyway, but is that the optimal moment to try and do one of those? I don't know much about the
so we do that I can't remember what point it comes up in the questionnaire actually. But what is your point? Do you prefer it to happen earlier or later?
Well, I just wonder, like, my hypothesis for the way people get bored and stop just like is if you ask them to do 10 of these, that they maybe do a couple of them quite well and then they kind of lose interest in or whatever. And like halfway through the profiles, you just say, choose the one on the right. I don't care what the things are. Choose the one on the right.
Yeah, so a better way of getting at that, which is possible, is just looking at whether people's preferences systematically vary over, you know, the first 5 versus the second 5 choice tasks. This is like technically an assumption of the method and a robustness check or some sort of data quality check. We haven't got to the point where we've done that yet, but that is the way that we'll check for like declining attention across the choice tasks. But it doesn't get at just absolutely low levels of attention from any given respondent.
Like the time that people took to choose.
Yeah, we collected the time for the overall questionnaire. So we have that data. I haven't got it on a slide here, but I should add that.
For every choice, because I think this is like how I understand it, a very nice way to check whether people after 5 questions they just pick one.
Yeah.
Where it's like obviously they didn't take the time to read the attributes.
Yes, yeah. I mean, you would expect people to get faster as they go through the choice task, but yes, clearly if they're taking sort of 5 seconds to do it, then this can't be a serious attempt at responding. Yeah. Yeah, I think we should do a lot more stuff along those lines.
But you don't have
We don't have that here. Sorry. Yeah, we have the data. We also just don't allow people to progress too quickly. So if you want to get the money, you've basically got to stare at a screen for a bit, at which point you might be slightly incentivized to pay attention, or it might be the least bad option available to you, and so on. But yeah, an important part of the next step of the analysis in this project is to do these various robustness checks and sort of empirical checks on data quality. Okay, since this is a quant methods, I said the last thing before results and then the last thing before the analysis. Since this is a quant methods seminar, I wanted to talk a little bit about like the quantitative machinery behind analyzing this type of experiment. And this, the main idea here is to estimate this estimand called the average marginal component effect, which is not the same as an average treatment effect and has certain important advantages in terms of power. And so I'm just going to present a few examples of how, if you try to get at the average treatment effect in a factorial experiment like this, you will just very rapidly run out of power. So assume this square is the size of our sample, the area of this square, if you like. If you just have a simple experiment with one binary treatment, on or off, the correct model for the average treatment effect will be something like this. And intuitively, I'm only giving the intuition here, but intuitively, everybody for whom the treatment is off will have the value of the outcome alpha. And everybody who has the value of the treatment on will have alpha plus beta 1. And so you can think of treat 1 equals 0 somehow being estimated off half the data. The equation doesn't quite work out like that, but as the proportion of treat 1 moves closer to 0% or closer to 100%, the standard error on beta 1 increases, right? So if you keep that in your head and think about what happens if we have 2 binary treatments, so now we've got treat sub 1 and treat sub 2. There's now 4 groups in the data, 2 multiplied by 2. Clearly, you could have them both off, both on, or one or the other of them on. The correct way to get the average treatment effect, which is not what we do in this paper, then involves running a model something like this, with the 2 indicator, 2 dummy variables for treat 1 and treat 2, and then their interaction, right? So I've highlighted here what's different from the last slide. We added a treat 2 and we added an interaction. And you can think of each of beta 1, beta 2, and beta 3 as now being estimated off a quarter of the data in some intuitive sense, right? Because only a quarter of people have treat 1 equals 1 and treat 2 equals 1. These are the people that will be in this group, and this is what you get for beta 3. Another way to think about this, which is slightly more technically correct, is the proportion of people for whom this term equals 1 is now a quarter. And since that's closer to either 0% or 100%, the standard error gets larger. If you then add another binary treatment, 2 by 2 by 2 equals 8, you're splitting your data, you're estimating each of these coefficients off 1/8 of the data. You have to have this very large equation with 3 two-way interactions and 1 three-way interaction. And the proportion of people with, for example, beta 7, or for whom treat 1 times treat 2 times treat 3 equals 1 is now 1/8. This is getting closer to 0%, and so your standard errors are growing larger, etc. So this is a nightmare if you want to look at 10 job attributes all at once, because cursive dimensionality, it will just blow up. So Hain-Muller and colleagues proposed this alternative estimand called the average marginal component effect, which gets around this problem and allows you to look at many, many attributes at once. So typically, we'd be thinking about the average treatment effect in an experiment, which if you just have 1 2-level treatment or attribute, put it in job choice terms, it's just the difference in the average outcomes between the treated group and the control group. This is very simple. If you then complicate that 1 level further, you can think of an average marginal effect. So say you're looking at the effect of aspirin 0/1 on blood pressure, conditional on somebody being overweight. I'm just some binary split of are you overweight or not. You could estimate that marginal effect. It's the ATE in one subgroup. And you could also estimate the ATE in this other subgroup where overweight equals 0. And if you average across those two things, you have an average marginal effect. If there's no interactions, this becomes the same as the average treatment effect. But if there are interactions between your treatments, it will not be the same. If you then complicate that 1 level further, you get this idea of the average marginal component effect. So this is the difference in average outcomes between treatment and control groups, i.e. those for whom the attribute is on versus off, averaged over the joint distribution of all the other attributes. So we're just allowing all the other attributes to vary however they like, and we're just estimating the difference between the treatment and control groups, allowing all the other stuff to vary. So you can think of it as just having many, many, many subgroups in an average marginal effect type of logic, and then just averaging over them all. So to show this graphically, here I've got a situation where there are 3 binary treatments, so 8 possible combinations of those. And this is now, remember what the model looked like for 8 binary treatments when you estimate the ATE, got lots of interactions, lots of small groups. The correct model for estimating the average marginal component effect is just a dummy for treat 1, a dummy for treat 2, and a dummy for treat 3. There's no interactions in there. And so beta 1 is estimated off half of the data. That is the half for which treat 1 equals 0. Notice that's the case in all these boxes. And we compare that group with this group, allowing all the other attributes, that is treat 2, treat 3, to just vary. Just be relaxed about that. Beta 2 is estimated off half the data. That is the half where treat 2 equals 1, treat 2 equals 1, treat 2 equals 1, treat 2 equals 1. And we compare that to this half of the data, just allowing treat 1 and treat 3 to vary randomly. And then beta 3 is also estimated off of half of the data in the same way. And so by changing the estimand from the average treatment effect, where the more treatments there are, power declines rapidly because of cursive dimensionality, precision declines rapidly. Once you switch to estimating the average marginal component effect, the precision is no longer a function of the number of treatments at all. You can just arbitrarily add more and more and more treatments, and the precision on the precision on beta 1, the precision on beta 2, etc., will not decline. Instead, the precision of these betas is a function of the number of levels for each of your treatments. So in this example, I've just said that each of them has 2 levels. But of course, in my job choice experiment, they've got 4 levels. And so this is a very nice bit of sort of statistical jujitsu, basically, which allows you to study many more treatments in your factorial experiment without reducing precision rapidly as you go. All right. So we present the results using these kind of coefficient plots. It's a big old graph. I tried to make it as large as I could, but I've also just tried to walk through it. So these are the average marginal component effects estimated across our whole sample of 884 respondents. You can see that the vertical horizontal line corresponds to an average marginal component effect of 0. Things are either above it or below it. Each attribute has a commonly colored set of coefficients. So this top set of 3 or 4 coefficients, if you include the reference category, are the 4 for salary. The next colored block, which are the green ones, are the pension contributions, and so on. And the way to interpret this, taking salary as an example, is if somebody moves from having a 28,500 salary value in a job to instead having a 31,500 salary, there is a approximately 0.1 or 10 percentage point increase in the probability of somebody choosing that job.
The one with the highest salary, right?
So this is a pairwise comparison between 28,000 and 31,500. If you move somebody from having a salary of 28,500 to 49,000, the Boston teacher one, you get an approximately 40 percentage points increase in the probability of somebody choosing a job, holding fixed all the other job attributes. And we're able to hold them fixed because we're separately randomizing the value of each job attribute. Okay, so I'll do some more examples. You can see that hours worked per week, there's a lot of variation in the size of the coefficients. And so here the reference category is 40 hours per week, and all the other options are more hours per week. And so, for example, this most extreme one, which looks to me to be at about minus 0.25, this is saying that holding all the other attributes in our job profiles fixed, if we just change the number of weekly working hours from 40 to 60, which is a big change, people are about 25 percentage points less likely to choose that job profile. Are there any like clarifying questions about the interpretation of this graph? Every coefficient is a pairwise comparison between the reference category for that bundle and one other value of that attribute.
What is the dependent variable?
The dependent variable is whether or not people choose a job, yes or no. And so
Jobs have specific these coefficients, every different coefficient across 10 jobs, right?
Yeah. And so we're analyzing this using ordinary least squares, even though it's a binary dependent variable, because we want to express it in terms of a probability point change. But when we put the paper together, we'll show everything using logistic regression. It'll be harder to interpret, but it'll be more technically correct. Lars?
Yeah, this is really neat. Can you go back a couple of slides to the point where you say that, yeah, exactly this, how you use alpha is then an eighth of the data, and each of the betas is half. And the example before was just an eighth each. So how did that, is it the interactions that you then don't include? So Yeah, so the difference between the ATE model and then the next one.
And this one.
Yeah,
Yeah.
yeah, it doesn't have interactions now.
Yeah, so this,
Yeah.
yeah, so yeah, the AMKey, the interactions are not included in the model, which is exactly how you get the gain in precision, because you're not having to split the data into, you know, sort of multiplications of the different groups. And so if there are interactions, where do these interaction effects go? Well, they effectively just get swept up in the estimand. And so your estimate of the effect of a change in salary is calculated averaging over the joint distribution of all the other attributes in your survey experiment. One perhaps undesirable result of this is that if we ran our survey experiment again, but we just excluded, I don't know, frequency of working with young people, we would actually be estimating a different thing, because we would no longer be averaging over the joint distribution of the other 9 attributes. We'd be averaging over the joint distribution of 8 of them. We would hope that doesn't make a big difference, but that is the sort of price you pay to get the increased precision.
And how large is then the full matrix that you ran?
Right, so we've got 18,000 job profiles presented, and people have either selected it as preferred or not selected it as preferred. And that is the, you know, we've got 18,000 rows in our data set to get these graphs.
So the alpha is then 18,000. In the
So the alpha is the value for obviously everybody who got 0 for all the other treatments.
18,000 over 8.
1 divided by 18,000.
So the reason I preface this with like it's the intuition is that it's not quite true to say that it's estimated using half of the data. It's estimated using all of the data, but because of the way the formula for the precision of a binary predictor in a regression works, the more unique groups you've got in the data, the higher the standard error for that group. I'm trying to give the intuition that like when you include the all the necessary interactions, you're sort of splitting your data into more and more groups. It may be better not to have these statements here and instead just do it graphically, I think.
Yeah, Steve Strand.
Oh, Steve, hi.
Hi, Sam. This
Hi.
is really interesting, actually, because it does make life so much easier, doesn't it? But this average component estimate really does. I'm trying to think what the power requirements are, because you've got you've got 10 variables varying each over 3 or 4 values. I'm trying to think how big does your sample need to be to guarantee that everything has been kind of robustly randomized?
Yeah.
There must be some
so-
kind of power.
Yeah, so the key variable for determining sample size beyond the size of the effects you might expect to see is the maximum number of values across your attributes, across your 10 attributes. So say that 9 of my attributes have 2 levels and one of them has 4 levels. I need to power it to detect the effects for the attribute with 4 levels. And there's a nice shiny app power calculator available just as a web page where you can plug these numbers in and get the estimates. If you're interested, the average size of the median size of the average marginal component effects found in the literature is about 0.05. And so if you want to have a play with it, that's a sensible number to plug in. But yeah, your intuition is right that it's like to do with the maximum number of values across any of your attributes.
And what does that indicate for your number of attributes and values in terms of the sample size that you need?
Yes, so I mean, the reason we've got this number 884 is because that's the exact number that came out of the power calculator. If we have a maximum of 4 values for any across our attributes to detect an average marginal component effect of 0.03 or larger, which is about half what people tend to find.
Yeah. Thanks, Sam.
Thank you. All right. So substantively, what do we actually learn from this? Well, we learn that salary makes a huge difference to undergraduates' job choice. You know, this is a relatively modest increase in salary of around about, it's just under 10%. And you can see that, or just over 10%, sorry. You can see that makes a difference of, I think it's about 8 percentage points in terms of people's probability of choosing a job. You can, as we've already discussed, hours per week really matters. And remember that sort of theoretically, full-time people work a 40-hour week, but in practice, teachers work a 52-hour week. That makes people about 17 percentage points less likely to choose a job. So that is big. The most influential ones after that are the ones with the most dispersion. These early career retention bonuses that we're paying to teachers after 2 years, assuming that people actually know about them when making the choice of which job to do, these affect, you know, the 7.5K one adds about 10 percentage points to the probability of choosing a job. And then some things that don't look particularly influential are how often am I going to use the subject from my degree? How much flexibility do I have over hours? Remember, these are all young people. And social impact. This has a small effect. Caveats about the kind of construct validity of this and how people understand it. But for example, going from no social impact to significant social impact moves the dial about as much as a £3,000 pay rise. The way I'm getting that is just by reading off, you know, how far these are to the right of the vertical line for the coefficients. And if we follow that same logic of comparing the size of the coefficients on non-salary attributes to the size of the coefficient on salary attributes, we can estimate the monetary equivalent value of each of these changes. There's different ways we could have done this, but these are the examples we've got at the moment. So for example, people are in this sample indifferent between going from 6 to 17 weeks of paid leave a year and losing £8,000 of salary. They value that at about the same amount in terms of how it changes their job choice. Going from hours 40 to 52, people would have to be paid an extra £8,000 to be indifferent between, you know, to be not bothered about that change in hours. Work from home 5 days versus 0. This is a bit of an extreme comparison, but that's worth just under £7,000 to people in terms of their job preferences. Social impact significant versus none. It's worth just under £5,000 to people. And then right at the bottom in terms of their monetary values, changes to the value of people's pensions. People don't care about that when they're median age 23, surprisingly enough. And whether or not people work with young people, you know, the average person in our sample just didn't place much value on that one way or the other. So this is nice from a policymaker's point of view, I think, in terms of thinking through, you know, which of these are most important to people. You know, if we're going to focus our policy one place or another, which one should we focus on?
We're focused advertising.
Right. Yeah. So there are no costs. Well, this is 17 weeks versus 6, but, you know, teachers get 12. It's well known that teachers get 12, but all you have to do is kind of, you know, vividly inform people about that. And you may be able to change their behavior without incurring any costs.
Or social impact.
Or social impact. Yeah. Yeah. Right. So how are we doing for time?
We have till 2 o'clock.
Okay. And we've got some good time for questions. So this graph is a different graph. This is not showing average marginal component effects. This is showing whole sample marginal means. So you'll notice that there's no reference category here. It hasn't come from a regression. There aren't a load of dots on the vertical line. And the vertical line is probability 0.5, not average marginal component effect of 0. And what this is showing is very simple, which is, for example, focus on this dot that corresponds to no youth engagement, no working with young people. What this means is that across all of the job profiles that included this value, that appeared in the job profile, let's say, it was chosen 47% of the time. Right? The reason why 0.5 is in the middle here is because if somebody doesn't care about this at all, they'll choose job profiles containing it 50% of the time, right? It just doesn't affect their decision making. And so what we see here is just a value of the measure of intensity of people's preferences. We're not changing salary and seeing how you respond. We're just saying, how much do you like this thing, no youth engagement, or this thing, 2 days work from home? Because a measure of how often it's chosen is just a measure of how much people care about it, given that all the other things are randomized. This graph shows very similar patterns to the last one. For example, look, salary is really important and working hours are really important, like they're very spread out. This is a much better way of doing the subgroup analysis. So here is our subgroup analysis of maths, physics, engineering versus others. Red dots are those who did a maths, physics, or engineering undergrad, and blue are people who did some other undergrad. The differences are not particularly stark, is the overall takeaway here. There is perhaps a difference, there's almost a difference here in terms of maths, physics, and engineering people are less put off by doing a 52-hour week, or less attracted to that. But by and large, there's a lot of overlapping confidence intervals here. So we just don't find large heterogeneity in job preferences by undergrad degree subject.
Given we've got later than that, you'd expect some of them to be different by chance. So
yeah, we've got a boost sample of maths, physics, engineering people that we haven't added to the data yet, because we only just finished collecting the data a couple of days ago. But maybe that will reveal something, but still, there's just not that much. This is high versus low public service motivation people. So red are people who express high public service motivation. You can see some sensible results here, like if you're high in PSM, you're much less likely to choose a job that has no social impact. But then there's not as large differences around high social impact. This makes sense. So they just want a job with some social impact. Again, we don't see a great deal of additional differences here. So high PSM people are put off, are less likely to choose a job that uses their degree subject never. But by and large, not much difference. And then the last one is openness to new experiences. This is it's one part of the big five. Again, not huge differences. There seems to be a couple missing here. I'm sorry about that. Not huge differences. I think on, again, there perhaps a difference on degree, knowledge, never. So this is in line with the idea that people who are high in openness to new experience want to like be around ideas and, work with the ideas they've learned in their degree. But again, the picture is not much of a difference. So briefly, a recap of our findings. Our data suggests that undergraduates really care about extrinsic incentives when it comes to choosing a job. They care about money, they care about hours per week, and they care about paid leave. And we're able to put that in cash equivalent terms. Unsurprisingly, people care a lot more about pay now than pay in the future, but we're able to quantify it. So an equivalent pension increase in your pension contribution is worth 2,000. People are indifferent between the same pension contribution would be worth 2,800 now versus 1,300 when paid later on in their life. So people place like a steep discount on that. And teachers' lack of work from home, which is a new thing since the pandemic relative to other graduate occupations, is worth about -3,000 pounds. So we need to do something to sort of compensate for that, just to maintain the attractiveness of the teaching profession. I won't recap the subgroup stuff, but in terms of policy implications, this suggests that the current situation where we backload teacher compensation into pensions, like a lot of teachers' pay comes when they're age 68, is a pretty poor way of spending public money if we care about attracting people, because they just place a lot less value on money later than they do now. Your point about marketing campaigns, I think this is important. If we're just emphasizing mission, which the average undergrad in our sample doesn't seem to care about that much, this is maybe not a particularly effective way of attracting the sort of additional teachers, shall we say. These early career retention incentives, there's evidence that they boost retention, but this suggests that to the extent that people know about them, they may also boost recruitment into the profession. And as I said, teachers need to be compensated for recent increases in graduates home working and the lack thereof in teaching. Okay, let's go to questions and comments.